Hello, everybody. Hope everybody's okay. We're gonna start soon with a brief intro about what we're gonna cover today. Spencer, whenever you're ready.
Yeah, so I was getting a bit of funny feedback, so I was just sorting out what was going on there. All sorted. Welcome everybody to this webinar. Today we're going to be looking at the plan design. So just in here. So there's lots of elements that we're going to be looking at to do with the plan design today. So we're going to look at, first of all, how its basic CAD functionality works within ElectricalOM. We're going to look at how we create various symbols and our own symbols within the software. We can also bring in existing blocks from DWG files or even other ElectricalOM files into ElectricalOM, so you can use your own symbols as well as the ones that provide you within the software. We're going to look at where we're bringing in various external drawings. So if you have various CAD files or PDF and image files, we can bring them into ElectricalOM. We can then scale those, add them into different layers, produce different layer floors and layouts for your designs, and then use that to drop into our locations, things like socket outlets and light fittings. We can reference those elements and match them in to our core software where we're doing our schematic design. So where we've created socket circuits or lighting circuits, we can match them into the design. It will take things like lengths, number of points that we've put in the drawings, and it will take this data as we're doing our CADing and all this information and put it into our design calculations and schematic. We'll then look at things like producing legends and information, which the ElectricalOM will produce in the background and allow you to drop information and complete your drawings. We're going to look at some of the more intricate, complex parts as well to do with this. So where we have items on wiring codes, we can apply things like costs and time and these things. So we're going to briefly touch upon them. We'll show you how we can do printouts and produce the final drawings and how they also then work into the reports. This webinar is sort of a prequel up to the next one. So the next one will also cover Revit and how we use this functionality from Revit to bring into ElectricalOM, producing things like schematics and those things. Again, a separate element, this is to the CAD Plan Design. But it's a good stepping stone into its understanding there. So with that, this sort of a brief description then. I'm going to be here in the background while Dimitri's is doing a lot of the presentation about what we're doing in the software and how these things are operating. I've got the Q&A up, so if you've got any questions and those sorts of things, if you want to drop things into the chat or you want to drop things into the question and answer section there, please do. I'll be answering questions I can. Some of the things I'll bring up during it and just ask Dimitri to cover some of those points maybe as he's working through areas. I hope you enjoy today's webinar. Away to you, Dimitri.
Thank you very much, Spencer. And thank you, everybody, for joining today. Let me exit this PowerPoint. So that's software. Yeah, so we will cover some basics about CAD, which we assume that the user require to be able to understand, and some basic knowledge required for CAD functionality. And then we're going to go through the way of the workflow from the start point of creating a symbol to the point where we're going to place that symbol to the specific drawing that we're going to import in the CAD Plan Design, and eventually create a sample project, and then go through more complicated stuff and cover some other areas. And of course, it's a live presentation, so we welcome you to ask questions So we can make this, as more personalized or as more to the point as possible to meet the specific requirements that you may have. So the CAD Plan Design is an extra add-on in the ElectricalOM software and is located here. So that's the add-on of the CAD Plan Design, and so you can access it as you access any other add-on. And since it's an add-on module, you can double-click on it, basic stuff, and extract it from the main screen. So imagine if you have a dual screen scenario in the office, you can have one screen for the plan design, the other screen for the core software. So it's easier for you to follow the various, aspects of the project as you model it. So I'm gonna keep it maximized now because I don't need to, for the basic stuff to see the actual software, the core software. And what I will try to explain now is that this add-on, this module here, this area is a basic CAD package. So you have to think about it as a basic CAD package that contains all these tools that will enable you to draw CAD drawings and do basic CAD functionality, right? So this is something which you need to understand at the very, very beginning, because you can use this as a standalone, let's say, way of creating CAD drawings as well, okay? So it supports this functionality. So a brief introduction to the environment is the top bar here, where you see the various CAD tools like the draw line, draw polyline, rectangle, and other tools, and some editing tools like move, rotate, scale, explode. So as a CAD user, you'll be familiar with this functionality. So I would try to keep, the terminology the same and to make it, as straightforward as possible. And then we have other tools here, for example, which is to import external reference. So this is really important when you have an existing drawing, you want to import that into the software, and through that drawing, create your symbols, add your symbols there, place your symbols, and create your electrical schema plan drawing, which you want to deliver and measure things on it. And we have other stuff we're going to cover, of course, during the presentation, like bind the drawing, scale the drawing, fix the reference if you change the location of the drawing, and this kind of stuff. And of course, we have functionality to export the drawing. So whatever you draw here, whatever you create in this drawing, in this environment, you can export that to a format which can be shared with any other engineer or the client, for example. So you can export this to DWG or DXF or DNG and various other formats. So whatever you see here, you can eventually export that to DWG or DXF, which will be useful to share it with other people. Of course, you can print it directly from here. Other tools are like the list of materials, which we're going to cover, a 3D representation, which is important to make sure that you have created the model correctly with the 3D elevations to measure correctly the wiring lengths. And the area here now is the area where we create our symbols and where we keep our symbols. So this is the symbol library, and it's been we have this in categories. So we have the distribution category, for example, sockets category, lights category, so on. So you can create as many symbols as you want in any category that you like, okay? So there's any limitation here, but it's very important to know that the category has a meaning eventually in the symbol. So when you have a symbol in the distribution category, it means that it will be referenced differently in the software. So the software will recognize that this is something which can be eventually mean an electrical element in the actual model, okay? But for example, if you have something like an instrumentation, which might not mean anything to the electrical model as an element of the ElectricalOM, model, then this will not be referenced or will not be considered. So it's good to place your symbols in the correct category. This is what I will try to explain here, to be able to reference them in the actual model. Yes, Spencer?
Just sort of paraphrase that a little. So various
Yes.
elements here, certain things that will be put on there will not count as adding to the number of points. So where we're doing a design and you have a circuit, say like a socket circuit, if you was to put something like an instrument, such as a meter in there, it wouldn't count it as an additional socket out there. So during the design, it won't add on an additional load because it understands that that element from that item doesn't need to be counted in that way. So various elements have little properties like that to help along with the design and avoid additional loads being added where they're not necessary.
Yeah, thank you for that. Yeah, exactly. I think it will be much straightforward and clear when we're going to do an example with that, section. So we're going to cover this, of course, and the various options. When you right-click, you're going to see various options here, what these options are. And the rest of the area here is the tools here where are related to the pages. So the pages are the various layers or floor levels or electrical, drawings that you like to include in your plan design module. So you can have various floor layers here. In each floor layer, you can have various electrical components and this kind of stuff. So there is a lot of functionality here as well, which can be covered with the right click, and some tools here to help you with that. And of course, other functionality here where you can assign, various colors. But we're going to cover this with the example. Here is a design tools which are related to electrical design. So any specific to electrical design should be used from here. Other tools are the update labels. So we can update the labels from schematic diagram to plan drawing and vice versa. So there's an option for that as well. So you can reference exactly the same stuff in your electrical, schematic diagrams, considering the plan drawing symbols as well. Here is the tools for creating legends and some architectural tools like draw walls and spaces and columns, which might be useful if you are not have been given the CAD drawing, the DWG file, for example. So you like to create that through these tools, which are going to help you, get a plan drawing design through the CAD Plan Design functionality. And some other tools here which are related to referencing the circuits of the selected symbols. So each symbol, for example, a socket, will be referenced to a specific circuit in the core software. Okay, so this area will explain and contain some functionality to help you with this assignment and to give you an idea of what's going on considering that particular selection in the drawing. Of course, this is the properties of the selected symbol, and the circuit groups are an important functionality which covers the selection and what that selection means as a group of circuits. So we're going to have, for example, a number of socket points placed. Those socket points belong to a specific circuit. So this area will explain exactly what's going on, which wires are taking place, which symbols are taking place, and why the length measured is the one that's been given. So it's gonna cover all the the measurements and give you an explanation, like a breakdown of all the components that take place during those measurements. Of course, it would be much straightforward with the example. So I think I've covered the very basics of what this tool is, and the next thing is to bring an existing drawing in. Okay, so I'm going to use this functionality, the external reference, and I'm going to select a DWG drawing. So you see here the way have my drawings. I have my drawings in separate DWG files, and this is a useful, a way of doing it, because you split the project into floor levels, for example, or to block of specific drawings that make sense to you, and it's not to make it more specific to what you want to deal with. And of course, it will be much lighter during the usage, because you're not going to see the whole project. If you are talking about a high building, for example, with many floors, it makes sense to split that into several drawings per floor level, for example, instead of having one huge drawing which you can put things on that drawing. Okay, so it's good to have them separate. Of course, you can work in any fashion you like, but this is what we recommend. Okay, so this is the ground floor drawing, and you can see that this is behaving as a unified entity. So if I move this, so how I move it, I just select it and click there, and then drag my mouse, and this is a movement. So this is basic CAD, functionality with grips selection and moving through the grips. Okay, and you can see that this is a unified entity. It's one figure. Okay, so in case you would like to make adjustments in this drawing, okay, you can't make it the way it is right now, because this is a reference drawing. So you have to go to your CAD editor, do the adjustments, and then reload that external reference into the plan design. Or you can bind it. Okay, so by binding this drawing means that you will lose the reference. Okay, you will lose that unified entity, and it will be converted to individual figures. So for example, you're going to have lines, rectangles, and other figures that all of them are part of this reference drawing. Okay, and this needs to can be done through this action here. So bind external reference. So when we need to do that, we need to do that when we want to share our drawing with other users, because the other users will not have that specific external reference drawing, or if we want to leave it as it is, we need to share the external reference as well. So if I go to the properties of this drawing, you will see that it's telling me that this is a reference figure, okay? And the location of this reference figure is in this directory, okay? So it's very important to understand this, because this is how the external reference methodology works, okay? You have an existing file which you reference within your drawing. So if you want to share this file with somebody else, you can't share it as it is. You have to bind it, or you have to share that external reference as well, okay? But when you share it, you have to consider that this directory, which it's under my name, for example, and under something which I've decided to put, will not be the same like the users or my colleague, okay? So the software will not be able to see this exact directory. So to make things easier, you can use the use relative path, okay? So what the relative path is, of course I have to save it first, is that it will see only the directory where this drawing is being saved, where this ElectricalOM file is being saved. Okay, so it makes things easier. In any case, you can fix the reference using this tool here, fix X reference, where you will be asked to select a folder where those references are. Okay, so we have this functionality to help you when those references are not visible or are kind of lost in the drawing. So you click there, and then you select the location of those references, and then the software will go and fix them, and you have to save and reopen the drawing. Okay, and then and that's it actually. So it's important to understand the reference idea with the actual figure idea. which it's the binding here. Okay, the other thing which is important.
Sorry, just before we move on, there has been a couple of questions that have popped up about importing.
Yes.
And there is a note. So versions from 2018 onwards at the moment don't seem to be recognised within the plan design. Is this
Yes.
something we'll be updating in the future?
Yeah, we were looking to do that. There are many compatibility issues with the existing, because it's part of the core functionality as well of the core software. So we are dealing with some other issues there. So that's why we have postponed that update for the version. But there is a way to to convert the 2018 to an older version, and through this, for example, you can download the DWG converter from Autodesk to do so, where you can convert the 2018 edition to an older version, and then it should be okay. But it's something we're looking at, of course, to do in the future, so you don't have to do this. You have to go through this process.
Okay. The next question that I'm not sure if we're going to cover this in today's, but I think it's worth asking the question. So when later on, when we're creating layers, can this then be exported back out to the X reference so changes can be made on the base model? So I think we'll cover a little bit of are we planning on covering a bit of the export functionality today?
Yes, so whatever layers we're creating here, they will be part of the export, okay? So all the layers here are going to be part of the export. Now, the benefit or the advantage of having this external reference as external reference is that you can make changes to the entities, to the layers of that reference as well, because now you see that this reference is inserted like that. But if for any reason I want to make changes to the layers, I don't really need to go to the CAD editor and do the changes and then refresh the reference. I can quickly go here, xref layers, and here it's going to list me all the layers that this reference has. Okay, and through this list of the layers, I can make changes. For example, I can hide some layers that I don't really want to. Okay, and the quick way to pick a layer is by selecting. So if I select something, you see it's picking the layer. So you don't have to read the text and try to figure out which layer this figure belongs to, so on. I just select, the figure, and then it will be selected in the relevant layer. Okay. So, for example, if I don't want to show these hatches, I just deselect them and press OK, and now my external reference is without these hatches. And you can imagine in the drawings that you're gonna get, you may have, already placed the electrical symbols there, the fittings and stuff. So in some cases, you want to use them to reference your symbols as a reference point to place your symbols. But at the when you finish that, you want to exclude that layers. You want to hide them. So the way to do it is to go to the layers list here, okay, and just deselect the layers. Okay. So that's another thing. Another thing which it's really important to know is that when you have external references, by default the software plays them as monochrome. Okay, monochrome overrides the pen color properties of all the figures in that particular reference to a monochrome value, which is this color here, which you can change if you want. Okay, so usually you want to work like that. So you have the reference as a gray color as a background, then you put your symbols on top of it, and which will be with larger pen width, so when you print them are obvious that we want to focus on the electrical aspects of the drawing and not the architectural stuff. But in any case, you want to use the colors of the external reference. You can change that to no. Okay, so double clicking or choosing the relevant value, And then you see you're going to get the relevant colors, okay, depending on what the drawings are. So one benefit of this approach is that you're not losing the line types. So you see here, it's this line type, but if I'm going to monochrome, it's a straight line type because we're overwriting this line type, okay? So in a case where this line type is important for you, okay, you have to choose not to use a monochrome. And then if you want to bring everything back to one color, you can go to the layers list, okay, and then change one color, for example, this color. Say okay, and then we'll ask you if you want to apply the same color to all layers, okay? So that's a workaround if you want to cover the case where the line types are important, okay? So you skip the monochrome, you say no here, then you go to the layers, and from the layers, okay, you choose a color, and then you overwrite the colors, okay? Then you have a similar, result, but with the line types, which might be important for you, okay? So that's one useful functionality here. And so the next thing which you need to do, of course, is to start placing the symbols. So we have the drawing, but before doing that, we need to make sure that the scale is correct. Okay, so how we are doing it? We just need to measure through this tool, which is measure distance, something which is known, or we pretty sure know what should be. So I want to activate the endpoints. Okay, so you see with the endpoints, I'm able to get exactly the point I would like to point to. And then this is 0.81. So 0.81, all the measurements are in meters in CAD Plan Design, okay? So 0.81 means 81 centimeters, which is something which looks okay, all right? So we don't need to scale this at the moment because it looks okay. It's scaled to the drawing, to the CAD Plan Design scaling. So in case there was a wrong scaling here, what we need to do, we need to select it like that, okay? And then use the external reference scale. And from here, we need to type the known distance. So in our case, let's assume that this should be, okay, 2 meters, right? So we know that this is 2 meters. So if I do that, it's asking me to choose 2 points that should be 2 meters. So 1 point and the other point. So you see it's scaling by 2.4. So it was 0.81. Now times 2.4 is going to cover the 2 meters. So now if I measure the door, it should be 2 meters. Okay, 2 meters. But in my case, I don't want this, so I'm going to undo. So I'm back to the normal scale, which is the correct one. So it's really important to scale the drawing to the correct scaling. Because within CAD Plan Design, I'm going to make measurements of the wire lengths, and to get the correct lengths, that's something we need to do. Now, I accidentally placed that drawing into that electrical layer and not in the floor layer. So if I move to the floor layer, you see that drawing is hidden. If I go to the electrical layer, it's visible. And the way this is behaving like that is because when you select a layer, we have a behavior to turn on or off or freeze, defreeze the layers based on the structure you see here. So all the downstream layers can see all the layers upstream, all the upstream layers cannot see the layers downstream. So that's why the floor layer cannot see what's inside the electrical layer, okay? So if I want to move this now to the floor layer, because that's where I should be, I can select it, right click, and then move to the selected page, which is floor. Okay, so now the floor layer has this one. The electrical layer is able to see that, but notice that I'm not able to select it. Okay, and the reason for that is because we have this auto lock button enabled, meaning that all the upstream layers will be locked for editing, meaning that will not be able to be selected. And the reason for that, of course, is because, as you know, if you have something in the floor level, you don't want to mess with that while you're dealing with your electrical stuff. You want this to be fixed. You don't want to accidentally move it or do whatever you want, do something with that. You just need to focus on your electrical stuff. So it makes sense to have it locked, so it will not be selected, okay? And of course, if you want to manually change this behavior, you can go to this layer list here, and you can change to lock or unlock from here, okay, or hide through these options here. So now I have it unlocked. So even if I am in the electrical page, I will be able to select that layer, okay? So it doesn't mean that since I'm in the electrical page, I'll not be able to do some CAD-based functionality, some basic CAD functionality. I can override this behavior through the layers list here, okay? So now I'm happy with this drawing here, and I want to start inserting some symbols in my drawing. So what I need to do, I need to create a structure of layers that makes sense to me. So here is my floor, which I will rename then to ground floor through here. You see the colors, of course. So we have colors of the layer, and of course color when you want to print it. Okay, you have two types of colors. And we have another option here to skip printing. Okay, we're gonna see this when we're gonna print the whole drawing. Some pages, for example, the floor levels, you don't wanna print them, so it makes sense to skip printing. And then we have the electrical layer, which in my case, I'm assuming I'm gonna model a single, a house installation here. So I will call this DB M, which is the main DB. And then from the main DB, I will right click, insert electrical layer, which I will name power. Okay, I will place my sockets there and my other power circuits like fridge, for example, or cooking units, this kind of stuff. But from the same layer, from the DB main layer, I would like to insert some other stuff like lights. Okay, and maybe another layer, which is, for example, security, and maybe other layers, which might not be related to the electrical stuff, but it might be required from to create them. So, for example, fire alarm, so on. So you can do whatever you want, actually. There's no limit here. Right, so for each now layer, you see that we can choose a color. So for lights, I will choose to use green, because when I see green, I would like to know that I'm considering lights with this color. When I'm looking at, for example, yellow, I'm considering the security. When I'm looking at, other color, maybe this one, considering the fire alarm. So having colors makes it easier for you to follow where you are dealing with without looking at the layers, because you know that green means, security, lights, and so on. Now, one other thing here is that I have this and looks okay, but when you want to print them, you want to have them all with the same frame, the same page size, and this kind of stuff. So in order to automate this functionality, so for example, if I want to put a frame in any of these pages, I have to go here, choose the page size, so for example, A3 portrait, insert page frame, like that, and that's it. But I have to do the same thing for every page, okay? So doing that, I might misplace that frame, so it's not looking, so you see the drawing is misplaced. So the way to fix that is to get rid of them from the first place and start inserting frames from the upstream layers. So what I will do here, I will create a frame from the ground floor. So even if I'm not gonna print it, okay, it's good to have the frame there because the frame will be my zoom in. So the frame will be the way for the software to know where to zoom. So I would like to zoom, for example, with this frame there. Okay, so even if I'm there, I'm zooming out with my scroll bar and I click the ground floor, you see it will zoom there, okay, and because of this frame. Now, if I want the same behavior to be for all the downstream drawings, I have to follow the same thing. So A3, landscape, and just insert, and it will be insert on the exactly same point. Okay, so I don't have to manually adjust it or put it to the point that will look the same. You just need to create the upstream frame and then select the same page size, of course, and then just put press insert or update frame. So I'm going to do the same for the rest of them. Insert, it's landscape, insert update frame. The same for this one. And quickly for the rest of others.
So I've got a couple of questions, if we can cover those as well while we're talking about the frames here.
Yes.
The first one is that we heard a question about inserting your own frames. So where we have people that have their own frames that they use in their own title blocks, they want to know if they're able to bring those in themselves.
Yeah. Okay. So have two things to say for that. The first thing is that you can do that, but it will be a manual process. You can see here that this frame, which we provide you, has already taking the floor name and the scale and the design and the logos and stuff, the design by and the revision by, which of course those things are part of the basic functionality here. So if I change the logo here, if I change the project title of the client, so if I just put here office or maybe let's put my name as a client, okay, and choose to update the frame, you see, here is my name. So this is an automated way to reference, to fix the frame and get the frame done. But if you want to put your own frame at the moment, you have to hide the frame, okay? And then insert the reference of your frame. So you're going to have your frame in a block, in a GWG file, as a block or as just basic entities. So you're going to bring those entities in and place them here. You can then bind them and change the text accordingly. Okay, but this is a manual process. You have to type the text manually, the same way you're doing in CAD. Okay, but of course we are planning to develop a functionality which you will be able to create the structure of this frame here. So you will be able to place your logos or any other images that you want and put the text to the positioning that you like. And this will be referencing, the text or the information from the project or the specific page automatically. Okay.
The next question, just on this as well, is where we've got the document numbers and the sheet numbers. Someone's asked if we would be able to have an automatic function for it to populate that information.
Okay, I mean, with what logic? We should have a logic of numbering. If it's going to be incremental number,
yeah, I would assume so. But I mean, at the moment, they're saying obviously it's a manual.
Yeah, it's a manual entry.
I mean,
it's a manual entry. Which
it's the same with our core software on the when we're doing the schematics. You put in your own drawing number and sheet number as required there. The drawing numbers and the sheet numbers might not necessarily be in the same order as what you have in the layers as within the plan design. So,
but of course, I mean, if there is a specific logic that we can follow and then put it there as a function, that should be fine. I mean, we just need the feedback to understand the logic. The other thing here is that you see that the frame references the name of the page described here. So if I choose DBM, you see that it's going to have ground floor dash DBM. If I go to power, it's going to have DBM power. So it's referencing the upstream layer with the downstream layer, and of course the scale that I'm using here. Okay. Now, in regards to the scale, because it might be a confusion here. When you want to scale the drawing, you don't scale the actual figures, the actual symbols, or the actual references. You don't want to do that because you're going to lose the measurements. The measurements needs to be in meters all the time because we want them to be in meters to get the measurements from the wires. Okay, so if you want to print with a different scale, what you are scaling is the frame. Okay, so even if you're not going to use that frame block here, you still have to define the page you want to print. Okay, hide the block if you don't want to use it, that's fine, but we need that frame, because you see those points here, those are the margin points which determine the scale factor, which you define here. So if I want, for example, 1 millimeter to be in paper, and the reality should be 200 millimeters, you'll see that what will be changed will be the frame. So the frame changes, not the drawing, okay? The figures there, everything that we created, that we inserted, remains as it is, only the frame changes. Okay, so this is a clarification that is important to understand. So don't scale the drawing, don't scale the figures. If you want to, print them in a larger page or a smaller page, don't scale them. Just scale the frame. It's this is the way you have to do it. Okay, and then of course when we have this done, we have this setup. Now you see, even if I select something here, it's zooming always to the same location, meaning that the frames are exactly placed on the exact location. So now we are ready to start inserting the equipment or the symbols that will describe the electrical installation. Okay, so now let's go to the symbols area here. As I explained, we have different categories, which you should place them on the right category. As Spencer said, will affect the way the software will count or measure the symbols, the wirings. So have them on the correct category.
Yeah, so there's a number of things there that we're doing with the various things. So things like architecture items won't allow you to connect wires and those sorts of things because they're part of the architecture. So when we're starting to drop wires and things into location, they won't connect. As we said before, with various types of symbols won't be counted towards the number of final points. Depending on the items that you have selected, there are various little behaviors that will make changes. Also within there that you can tell certain symbols to count as additional numbers and these sorts of things. But I think we'll probably show that when we show a little bit on how to import your own blocks from other
Yes.
from other items.
Yes. So now you see that we have already some existing symbols. So when you first run the software, you see that there are already some symbols there, but and of course you can create your own symbols. So as a recommendations, we recommend you to leave the existing symbols there, and if you want to create new, just create new, or use them as a reference to create new symbols. The reason I'm saying that is because if you want to share your drawings with other people that using the same tool, and you change that symbol, for example, that symbol on the background, there is a unique identifier, which will be the same as your colleagues' identifier. So there's going to be a mismatch there and a confusion, which of course there is a way to fix that with the functionality here, sync symbols from plant document. But it's better to avoid it. So, and the way to avoid it is to create your own symbols. So leave the existing symbols, just create your own symbols if you want. So for example, if I want to create my own distribution symbol here, what I will do, I will right click, create new. Okay. And then it will take me to the symbol editor, where I can start creating my symbol using the basic CAD functionality here. So draw rectangle, for example. So I'll draw something like that. And this cross here is the insertion point of this symbol. And in some cases, it makes a lot of sense because you want to snap those symbols to the wall. So this is the point where they will be snapped, to the wall. Or when you insert them, that's the point. For example, if it was going to be a lighting, you want to place it to the center point of that. So when you place it, when you it's going to get to the center point of that. So in this case, I would like this cross to be on the midpoint of this line. So I'm going to use the midpoint object snap and then place it there. So now I'm sure that this the insertion point of the symbol is placed to the midpoint. So what I'm going to do now, I'm going to draw a hatch to get this, DB hatch representation. So we have this tool, draw hatch. So I'm going to use the endpoint here. Okay. And then I just need to choose a solid hatch pattern, then okay. And this is my distribution board. Then I need to choose the category. Of course, since I was in the distribution board category, automatically this is selected. I will call it DB, I don't know, maybe 12 ways. Because imagine that you can have several distribution boards with specific, identifiers that eventually will make sense to you. You can count them differently in the using the wiring properties and this kind of stuff. Or in the plan drawing, you want them to be on a different scale or different, dimensions. Okay, so 12 ways might be, larger than the 6-way, for example, in this kind of stuff, or the 3-phase, the single phase. So it depends on how you like the period to be. So I'm going to copy that and put it to the legend description. So the legend description is important because eventually all these symbols will be put in a legend, and this is the description that we will use next to each symbol. And then final circuit points, we don't care about that because this is not the final circuit, so we don't care about that. Default elevation, that's really important. So what should be the elevation of this symbol? So the elevation, we're talking about the height from the floor level. So usually this is placed 1.4, 1.6 meters from the floor level, okay? This is your default elevation. It doesn't mean that this will be always the elevation for that particular symbol. You can change that after you insert that to the drawing, okay? But this will be the default that this symbol will take as the default elevation, the default parameter. Now, snap to wall, we want this because usually the distribution boards are placed, to a wall. So you want this to be snap to wall. That will be much easier for you to place them. Default wiring properties now. We don't care about that at the moment because this is a behavior when you want to auto-wire various symbols. For example, imagine sockets or lights connected to each other. Okay, so what should be the wiring elevation? For example, for the lights will be 3 meters. So you want the wire to always come from the ceiling level, which usually will be 3 meters. So that will be the case here. But of course, as I said, you can override those parameters later. But in this particular case, we don't care about that. Using legend, that's good. We want that because we want the symbol to be represented when I insert the legend. Monochrome, yes, we want that because this is not something which contains color. So we want this to be based, we want the coloring of the symbol to be based on the color of the layer that we selected. So in case you want to override the behavior of the color, we want to put specific colors here because we have a symbol that the colors make sense to that particular symbol. You have to uncheck that monochrome. So they will not follow the layers, color, but the coloring that you selected in that particular symbol. And that's it for this. And I have to save it. Successful save symbol. And this symbol will be presented here. Okay, this is my symbol. Now, because eventually you're going to have many symbols here, you can move the symbols you're using, often to the start. So I'm dragging and dropping them here to the start of the list. So I don't have to look at them. For example, if I have something like that, I don't have to scroll. If I have the list, like that, I don't have to scroll to find the symbols I'm usually using. I can just drop them to the position I'm on the top, so I can quickly reference them, get them, and drop them into the drawing. Okay, so now I'm gonna get that, but before doing it, I need to make sure that I'm on the correct layer. Okay, so now I'm on the DBM layer, which is the one I want, and I will drop it there. And you will see, because I have the snap to wall function, you will see that the symbol is automatically snapped to the wall. Okay, so I'm gonna disable those object snaps so it's easier to see that. So snap to wall means it's snapped to any line. Okay, any line, doesn't really need to be a wall, should be a line. Now, in some cases, you may have hatches in the drawings. Okay, so it will not recognize the snap to wall functionality. So in those cases, you should bind your drawings, or you should get rid of the hatches, or place the hatches on the below the lines. So there is a way to work around it. But the easiest way is to get rid of the hatches, so only the line remains there. So you can easily, use this snap to wall functionality. So the snap to wall functionality needs a line to reference. Now,
Sorry,
another thing
once
which
you
is
drop that into position there, Dimitri, could we just answer a couple of questions that we've had on the symbols, please?
Yes, of course.
So, firstly, I think we'll look at this one. We've got one question about the symbols and syncing with other users' libraries. So
Yes.
currently, the symbols that you will create on this version or on your desktop version will be saved locally to your version. Now you can save the file and you can import the symbols, but I do believe we are looking at a way to have a central library of symbols.
Yes,
For those that
exactly.
wish to have their library centralized between multiple users.
Yes.
I mean, currently, it's relatively easy as well. The symbols file itself can just be copied and pasted to other machines to move around libraries if they've been brought into one machine, or the symbols have been created on one machine. So there are other ways that currently to do it, but currently there is no specific central syncable location. But it is certainly something we are looking to have in the software. The second thing that's been asked is how do you get the symbols to scale to the same ratio? I'm assuming, Ian, you're talking about if you're importing your own symbols. Would you be able to cover that, Dimitri?
Yeah, sure. Okay, so I'm gonna escape now to cover that. So if you right click and you choose insert symbols from file, as Spencer said, you can browse to any ElectricalOM file or any WG file. So if I choose an ElectricalOM file here and choose that, you see that it's gonna give me a list of symbols. So that file is not created in this machine, it's created in another machine. So all these symbols, so for example, I don't have those symbols in my library. I can choose them and those will be inserted on the specific category, okay, which I will select. So for example, sockets and some other properties. So if I want to copy that there. And now during this insertion, you'll see that we have a scale symbols option. So usually when you have your own library, the symbols are scaled to a specific scale factor. It might be 2 millimeters or 2 meters, or depending on the case. So you have to do, you have to place one to see the scale. And after you figure out the scale, you have to put the scale here if you want to put them all, for example, check them all. So by referencing the scale, it will auto scale that symbols for you to match the scale of the drawing. Okay. So you have to do a trial to see what scale you have them, or you have to open your editor and check the scale there. But I think the trial is something which is the most straightforward, because you're gonna bring them in. Like now, I will have them on it was on the other category. So if I go to the other category, that's the one, or on the sockets, I'm assuming, yeah, those are the two I've just inserted. So if I right click and edit that, or if I bring it into the drawing, you see that it's looking good. It's okay the way it is, because the scaling looks okay. But you see the other problems. For example, the insertion point is not correct, because you like this to be placed on the wall, not vertical to the wall. So you have to fix it. And the other thing is that this is, I mean, since someone created this with these specific colors, I'm assuming that you like to use those specific colors. So you have to uncheck this monochrome option. Okay, and then of course you have to place this to the center point of this line. So eventually you're gonna get the symbol to be correctly aligned. So if I try this now, it's not updated. Okay, so yeah, I think you should rotate that as well. Yeah, so you have to rotate that. So I'm gonna use the ortho. Okay, save. Yeah, now it's working as expected. And you see the colors, that are presented there. Yeah, so that's one thing we should be noticed, is that the colors, the symbols should have this orientation. So either from top or bottom, the insertion point, if you want to align them to the wall. Okay, don't have them vertical, because the maths that we are doing to get the right positioning are assuming that you have them all horizontally placed like that. So it's just a way.
Yeah. Hopefully, that answers your question. If you're thinking about it the other way, if the drawing's been brought in and you're scaling it, the symbols that are standard within ElectricalOM are made to the existing scale of 1:1. So they will already be sized correctly if you scale your drawing to the actual size on that 1:1 scale.
Okay. Yeah, so if I, for example, choose to insert another symbol, and change that scale factor, so let's choose the same, for example, and choose another one. Let's choose this, whatever it is, scale symbol. So if I choose 2, okay, it will be, or 10, it will be scaled by 10. So let's go to the others category. If I edit that, so you see if I zoom in a lot, those are the grip points. So it's quite large symbol. Okay, so I have to figure out the scale factor now and scale it down. Okay. So you can use, for example, the scaling, insertion point, and then the scale factor 0.001, for example, zoom, extend, and that's it. And then you can, change it. So I did some quick commands here. As as in any CAD software, we have commands here. So by typing Z, it's going to give you all the zooming commands. Okay, so zoom extend, zoom all, zoom selection, zoom, previews, window. Okay, and we have other commands. For example, if I want to move, you type M, you type O, and that's the move command, where you can do your move, thing. So we didn't cover that at the very beginning. Sorry about that, but it's good to be aware that all these actions, all this functionality is part of some commands which are can be referenced from here. So if I would like to draw a dimension to see what this symbol is being dimensioned, so I can type dim, and then choose the aligned dimension. Okay, and then I will get rid of the grips so I can use, be easier for me to draw the dimension. And that's the dimension, okay? And everything is in meters. So this is 1 centimeter, okay?
Okay, I'm just conscious on the time. We're now over.
Yeah, I think we're gonna.
I think what we'll have to
yeah.
do is a second session because there's so much. We've only covered the basics.
Yeah, I will.
There's so much on the integration that we've still got to go through. Just answering one question that has popped up, which is, what key shortcut did you use to place the symbol on the wall? So when we drag a symbol out, if you've got the snap to wall selected in that symbol, it will automatically start snapping to the walls. In order to flip the object from one side of the line to the other, he was using the space bar. So when you press the space bar, it will just change it from one side of that line to the other of that snap that's been placed in position. So I hope that answers your question there. So Dimitri?
Okay. Unfortunately, there's so many things to cover. I will continue with some basic stuff, and then I think we're gonna arrange for another one. Okay. So I will place this there. Okay. Now, before placing it, we have options to start creating the network as well. Okay. So I will not do that. I'll just put it and right click. So this is my symbol, just to show you what this symbol means. So the symbol, if I go to properties, has various properties. One is the elevation. You see by default, or because I've created a symbol which has been elevated to 1.6, this is referenced like that. And the others are labels. So you can put labels there, dB1, for example, or dBm. Okay. So those layers, those labels, can be manually moved through the grips. Okay. So each symbol has a label which eventually you can put any text on it, and if you move the symbol, it will be moved together, but you can move it individually if you want to, okay? And we have, sorry about that, and we have a functionality to place the specific position of that particular label. So you see this is user because I manually move it. But if I want to put it on top, I can just put it top, or right or left. So in this, so this functionality is very important when you have a group of layers, labels, which you want to move with one click. So you select them all, you select the positioning, and that's it. You don't have to manually move all of them. And I will do an example now. So let's assume I want this guy to be here, and I'm happy with that. I will go to the power and put some sockets there. Okay, so I'm going to place some sockets. So I'm going to go to the socket category. I will assume these socket outlets. I'm going to edit that to make sure that the properties are okay. So I will assume one final circuit for that. Default elevation 0.4. This is the default placement. That's okay. Using legend, fine. Default wiring. 0, that's fine. So save that. And what I will do, I would take that and put it, you know, on the wall here, and put some layers, excuse me, labels. So let's assume I want this to be like that. I'm pressing the space here. Okay. Now I will select them all. Okay. You see that the DB is not been selected because it's part of this layer, so it's locked. So it's not take place in the selections. So I've selected only those. And another way to quickly select them all similars, you can right-click, select similar. So it's going to select the similar symbols that has the similar, you know, reference here. And I will go to properties and then go to label and say S1. So let's assume this is circuit 1. You see all these, all the labels are placed to the right side. But if I want those guys and those guys to be placed on the bottom, you can select them and say here. Okay, and the same with that. So you don't have to manually don't have to manually go and manually move the symbols. You just select what you want and then choose the label positioning.
Couple of questions that have popped up. I think it's the same question from both people. Just phrased slightly differently. Is about the default sizing of the text with them. They want to know if it's possible to change the default. Now, it's easy to change the label height itself by going into the properties. However, I don't think we have an option like we do to actually make a default size permanently, do we?
No, we don't have, but
it's
yeah,
certainly something we
we
look
can do.
at. I can imagine that would be a very useful feature for many people if you do use specific text sizes within your within your drawings.
Yeah, in any case, if you want to change the symbols, the size of the text for any symbol, I mean, you can select the symbols. So, and then you can change the size here. So 0.1, for example. Okay, so it's quite easy and fast.
Yeah, I think there might be a few option availabilities there for setting various defaults, which we can possibly look at for a future update.
Yeah. So I will now get rid of them. I will erase them. I don't want them because what I want is to start creating the network while I'm inserting those symbols, which is the power, let's say, of this CAD tool. So I'm going to close this. So we'll take it back to the core software. So now it's taking back to the, to the original position. I'm going to go to DBM, go to distribution, get my DB 12 ways, put it there, and before right-click, so right-click or escape is closing the action, sending the action, I will check auto create circuit after insertion. So I'm right-click, and now the software will ask me about this circuit. So this is an actual circuit that will be created in my model. So I want this to be DBM, of course. I want this to be single phase, and I want this to be 12 ways, okay? And we have other options, so what should be the description? So main DB, and if you want to show the prefix in the label or feeder or way, you can do that as well. Usually you want to show the prefix for the distribution board. So I'm going to click OK. And you see now that we have the DBM as before, but now this DBM is not just a symbol, it's something which is referenced by my schematic diagram. Okay, this is my DBM now. So it's already created the model with the 12 ways panel. Okay, and now this guy here, if I select it, you see that we have reference already populated here, which says DBM main DB. Okay, so if I don't have the reference for any case, so let's assume that I'm gonna deassociate this. So I'm escaping. You see there's nothing here selected. I can quickly associate it by selecting it, click the link, so it's gonna choose for me the right item, and then click assign, okay? And when you have assigned, it's gonna be listed here. So now the circuit length is 0, the final circuit of course is 0 because this is not the final circuit. So those are the two measurements that we're doing. But for this main dB, we want the circuit length from the main, from the supply side. So for example, this is a house, so we're assuming there is a metering somewhere, which we want the cable from that, you know, it's from that tails conductor or the main cable being supply that particular distribution board. So what we're gonna do, we will place a another symbol for the metering. So I'm gonna place it, assuming, let's assume, yeah, there, okay. Notice that it's not asking me about any reference. It's not asking me to create any symbol like when I inserted that dB, because this is not a something which can be created as an electrical element in my model. Okay, but I'm using this as an important, you know, node in the drawing. So what I would like to do here, I would like to draw a wire from this guy to the metering to measure the length, and of course to show the path of this wire. So what I'm gonna do, I will use from the design the wiring tools. So draw wire. Okay, so before drawing the wire, it's good to make sure that you are on the correct reference. How you're making sure that you're on the correct reference is, of course, to see that you're on the correct reference like that, or to just select the symbol that makes sense to you. So if I escape, there is no reference, but if I choose this symbol, you see, it's selecting the reference. So this wire will be the main cable which will be defined here, okay? So the length here will be updated by the length of this wiring. So it's referencing the same electrical component. So I'm gonna draw wire, and now I need to define the elevation of this wire. So what should be the elevation? So it's coming from the ceiling area, or it's coming from the floor area, or there is a tracking clip direct on that wall going to that metering, depending on the case. So I'm assuming we're going through the ceiling down to this metering. So I'm gonna say 3 meters, and you have option if you like this to be curved or straight line. So I'm gonna do that. I'm gonna use the ortho, okay, and I'm gonna go there. So notice now that when I'm gonna select that, it's telling me that this is 8.7 meters, okay? And I can apply that with this button, and this now will be applied on the circuit editor. So I know exactly that this length, this run is 8 meters. And if I want to make things more precise, I can navigate to the 3D view here to see exactly how this is measured. And you see here the elevation of this guy, which is 1.6. This is the wiring going up to 3 meters and then going down to this metering, which by default is elevated to 1.4. So if I want to change this elevation to 1.6, for example, of this wiring, so let's make it 1.6. I'm expecting that my length here, when I click refresh, to be reduced by 20 centimeters, okay? 8.5 now, because the elevation of this guy has been increased. So this 3D representation explains exactly how this wiring is being measured. And that's it. Now we're ready to move to the power. So I'm gonna cover one power circuit to show you the power circuit. And I think we need to then arrange for another session, unless you have questions and stuff to ask.
Yeah, I'll need to get away, otherwise I'm going to be in trouble with the boss.
Yeah.
And when I say the boss, I mean the wife.
Yeah, and we have to congratulate Spencer because his son is becoming 3 years old. So happy birthday to Sebastian. So I'm gonna quickly do that now. So I would place that there. Before doing that, I would like to show the wiring, which is something good here because it's going to wire all these sockets together with a specific elevation. I'm going to leave that to ceiling as well. You see those are wired now. Okay, I'm going to assume this is a ring circuit. So let's put something like that. I'm going to right click. Since I have this checked, it's going to ask me about this. So I'm going to call it ring 1. I would like to show the prefix, okay, but I would like to show also the way it's been fitted. And also here, from here, you're selecting which way you like to place that. So I will click OK. So I would like this to be on the first way. Ring circuit, OK. Now you'll see that we have the ring circuit created here with 8 points. Okay, 8 points, and it's giving us the length as well. But of course, now I have to make some adjustments because this is a ring circuit. I want those two guys to be connected back to the panel, and I want those two guys to be connected together. So I'm going to get rid of that, delete it, choose wire by selection, select those two and right click. So those now are wired. I can change the wiring line like that if I want to, or I can leave it as it is. And now I'm going to wire by selection this guy back to the panel, right click, repeat, this guy back to the panel. Oops, I choose the socket. So this guy back to the panel. Okay, now you see the text now is kind of one on top of the other. So just move it a little bit. So it's much easier to, of course, you can apply the, the logic that I described earlier with moving things around. So now this circuit, if I go to design, has the right length. It's quite long. And the reason for that is because we have all these up and down drops, okay, which increase the length a lot. And of course, you can change the elevation of any of those if you want, as explained earlier, and then the length will be updated as well, okay? And of course, the 3D. Now, in the 3D, something new which we have created is not available in the current release, but will be on the new release, is the option here where you can choose to show or hide a specific arrangement. So if I want to show to hide this ring, I can check that, and you see we'll hide that. Because if you have many circuits here, you like to focus on some specific one at some point. So by checking or unchecking that, it's going to give you the arrangement, okay? So this is something new. And of course, you can also choose to focus to a specific, with zoom on, with the zoom functionality. Okay, and I think
there are a few questions. I think just to quickly mop up. I'm going to start with this one that's just popped up. If we edit the cables from the symbols that have been inserted, they don't seem to keep locked to the symbols. Is there any way to enable this? They should be locked to the symbols. Are you aware of anything with that?
Can you repeat that, please? Because
yeah, it seems that they've been putting wires in between symbols, but when editing or trying to move them, it seems that the cables aren't staying locked to the symbols.
So the cables are independent of the symbols, okay? Yeah. So if I move this guy, the cable will not move. I have to manually move it. Okay.
I mean, there are other features in here that we haven't even touched upon yet, which is sort of the wire by selection, so it will automatically drop wires between and these sorts of things. But I think that's something really for the next webinar. And along the same lines, we've got a question about can we have options for cable tray in case the grouping of cables? size. What we've done is we actually have within, and again, this will be something for the next one, is we can use multi-lines. And we've got a number of predefined multi-lines, and you can also set up your own for different trunking sizes and run your wiring along those or within those multi-lines to show the path of trunking on that system. But again, that will be something for the next one. How do you show the cable route of the distribution circuits to the DBs on different floors that are fed from a central point, i.e. the ground floor? So this will be where you've got different layers, I'm assuming. So you'll have ground floor, first floor, second floor, and you want it to show sort of the length between those floors. Is this something that might be better to be covered in the next webinar?
I think there was a question which was asked in the emails, which I should cover it. So I'm going to quickly show that. So assuming that this is the first floor, you see I've created another layer, okay? Another floor layer through here, and I inserted another floor layer there, which will describe the DB. So this is DB 1. So if I quickly get rid of it, so DBFA, okay? So that's DBFA right there, okay? So what we're doing now, because there's no specific reference between the floors, what we're doing, we're creating one wiring, okay, like that. So that's the wiring. And then we say use arrow, okay, no, at the end, sorry, use arrow at the end. And then you say DBM. Okay, so now this arrow is telling you that from here you're going to this DBM, and you can apply a specific length you want to cover. So will be the floor level, for example, like 3 meters. Okay, or if you know the position of DBM, you can cover some extra location. So for example, you know that the path will go through this line and then down. So this line is measured as well. Okay, so this line is considered as a length, and you can apply extra length for going down to that particular DB. And now that's the way you're referencing that case. Okay, is by using the wiring arrows. Okay, so hope I covered that.
I think so for now. I mean, I think there are a few other ideas that we've been talking about previously in development of these various features. And as we've said in the previous webinars, if there are features and things that you think that you would need as part of your design, then by all means let us know. We take all requests for features very seriously. I mean, the software is developed for the end user. So, because yeah, I mean, we've only really scratched on a lot of the functionality that we have here. So it'd be really good to showcase a lot more of the power of what we can do with this. So that would be great. And thank you very much, everyone, for attending. And well aware that we've run over by quite a lot of time here. So appreciate you taking that time out of your day. And thank you very much from myself and Dimitri. Leave over to you.
Thank you, Spencer. Happy birthday again to Sebastian. And of course, thank you everybody for your time, and I hope it was worth it. And we're gonna plan another one soon to cover the rest of the stuff, which I believe are important, and to make sure that we give you a nice overview and a nice understanding of the functionality here, and of course get as much feedback as possible to improve the system. So until the next one, thank you very much, and stay safe as always.
Thank you.